More like a review. Most of you, hopefully all of you, already saw these properties presented, I think, from 5th grade and on, so 7th grade, okay? So, should be a piece of cake. The only thing I'm going to approach it in a way so that we can go a little bit faster and cover as much as we can before we get to where I want us to be for tonight's home plate. So, copy these terms, please. There are only 4 of them for right now. No. Instead of the Ferrer model, you're going to write these terms down. Vertical angles are are the non-adjacent angles formed by 2 intersecting lines. Adjacent angles have a common vertex and a common side, but no common interior points. Complementary angles are 2 angles that add up to 90 degrees, and supplementary angles are 2 angles that add up to 180 degrees. So copy that. This should go instead of your Ferrer model in that section where you usually put your Ferrer model. Okay. So copy that, and then I'll elaborate more on that as soon as you're done. All right, let's see. While you're finishing up, let me elaborate a little bit on some of the terminology I'm going to be using aside from those that you just wrote down. So a quick recap, let's see. When you were introduced to angles, I'm going to start all over with that also. Here it goes. Hopefully, if they didn't introduce it like this, maybe this will like ring a bell or get you a little bit more clarity on the concept of angles. Here we go. An angle, before it's formed, has 3 parts. One of its parts is this one. This is what we call a ray. A what? A ray. And that's pretty much something that is obvious in regards to, I'm thinking that they probably got this terminology from what they observed from the sun. Who notices that the sun expels light, right? But nothing goes to the sun because it's coming from the sun. That's why they're known as rays of the sun. Does that make sense? So imagine that this is the sun. Look up. This is the sun, and anything coming from that is a ray. That's why this is known as a ray. But as soon as we get 2 rays coming out from this same point, now this is forming an angle. How many rays? 2 from the same point. This same point that they both share is called the vertex. Now, most of the time when you were introduced to angles, they probably gave you a point for one ray and a point for the other ray so they can label them. And they label the vertex a different letter, such as B. So that in order for them or for you to write the name of that angle, the symbol for angle is like this, angle. And the angle this is forming is angle A, B, C. Because this ray plus the vertex plus this ray make up this angle. So this is angle A, B, and C. Another way of writing this would be angle C, B, A. C, B, A. Which is the only letter that did not change? B, because that's the vertex. That's why it doesn't change. You understand? All right. So with that was a good intro, and that was a good covering the basic terms. Below where you wrote your terminology, I want you to copy this. And we're going to label this 1, 2, 3, and 4. Change that 3. And right now I'm going to begin first with adjacent angles. Adjacent angles. Once again, the word adjacent means next to. But according to the definition for adjacent angles is that they share a common vertex. Do we know what a vertex is? Yes. And they share a common side. So adjacent angles, I'm going to say, are angle 1 and angle 2. Angle 1 and angle 2 share the vertex and share this side. Does everybody see that? Okay? Talk it over to your neighbor and let them know what's another set of adjacent angles that are found here. Lisa. What is it? Angle 3 and angle 4. Yes, they're side by side. They share the vertex and they share this side right here. Who can give me another set? Yes? Angle 4 and angle 1. Oh. Yeah, I did that to see if you were paying attention. So let's see. Are these side by side, sharing the vertex and one side? Yes. And we're missing one more. One more. Francesca. Angle 2 and angle 3. Are they side by side, sharing the vertex and the side? Yes, those are adjacent angles. Okay. Now, if angle 1 and 2 are adjacent, and 2 and 3 are adjacent, 3 and 4 are adjacent, 4 and 1 are adjacent. Look at the definition for vertical angles. Vertical angles are non-adjacent. So tell your neighbor which two angles are non-adjacent. Which are non-adjacent? You can give me the first set. The first set of non-adjacent. Anyone? Anyone? Francesca. Angle 4 and angle 2 are non-adjacent. That is correct. That means that they don't share a side. They do have the same vertex, but not the same side. And what's another one? Another set? Beto. Angle 1 and angle 3. Angle 1 and angle 3. That is true. Those are vertical angles that are non-adjacent. But they have also a special property. Let me show you the property for vertical angles. First, I'm going to start with 4 and 2. Pay attention to this one. Here it goes. Okay, so I'm doing the best I can with my little tablet here. But if you notice, who noticed that, let me zoom in so you guys can see it. Who noticed that I highlighted the entire angle 4 in here? Okay. And you said this is vertical to this one, right? So watch. If it is vertical, then it has a special property. What is that property? Tell your neighbor. That vertical angles are also what? That is correct. Matthew said that they are equal in measure. So angle 4 equals angle 2. Therefore, what else? Angle 1 is equal to angle 3, or measurement of angle 1. We got it? Copy that, please. And of course, the easy ones are the last two, which is complementary, two angles that add up to 90 degrees, and supplementary, that two angles that add up to 180 degrees. Yes? Yes, Mr. Q. All right, good. Ready? Okay. With that said, example 1A. Write this down, please. Example 1A. Use a diagram to find each angle measure. So you're writing, if measurement of angle 1 is 37 degrees, find measurement of angle 3. This is the diagram that they give us. Now, for these, this is the way I want you to present it. At the beginning of the school year, we did just a couple of times, I had you do window notes so you guys can know what they were or can know what they are, but I found out that you practiced a lot of it last year, right? Very good. So today I'm not going to ask you to do window notes, but I am going to ask you to set up a 2-column proof. So check this out. You set up the 2-column proof like this. Label this one reason and this one property. And it's very similar to the window notes, right? Yes, Mr. Q. All right, good. So first things first, what did they give us? They gave us if measurement of angle 1 equals 37 degrees, find measurement of angle 3. Where did we get that from? The problem. And where did I get the problem? From Mr. Q. I gave it to you, right? That's why we write given. Question, which 2 angles are they talking about? 1 and 3. Tell your neighbor what you know about angles 1 and 3. They're what? The vertical angle. So the property that we know is that they are vertical angles. And what does that say, Beto, using those angles?
That they're across from each other, and 2, they're equal.
So the measurement of angle 1 is equal to the measurement of angle 3. Is that what you're saying?
Yeah.
All right. So look at this. So they were saying measurement of angle 1 is 37 degrees. Find measure 3. That was given. But we know that those 2 angles, they're equal because of vertical angles. Therefore what? Tell your neighbor. What would you write to conclude? Therefore, Gio. Help them out. Jasmine. Olivier. Okay. Ivan. Measurement of angle 3 is equal to 37 degrees. That is our solution. Piece of cake? But you see how the thought process goes straight through, and then you need to use a property in order to, I guess, justify what you're writing for the next step. So do this next one by yourself. Example 1C. And let's see how you do. It says, example 1C, use a diagram to find each angle measure. And it says, if measurement of angle 1 is 42 degrees, find measurement of angle 3. Copy that and go. So, fairly simple. At the end, we conclude that measurement of angle 3 is equal to 42 degrees. Well, 42 degrees. Why? Because they are vertical, yes? All right. So before I give you the last piece, look up. You don't have to copy this. Look up. Look up. A right angle. Angle what? Everyone. TQS or angle SQT, okay? Acute angles are angles that are less than 90 degrees, so you would tell me angle PQT and angle SQR or RQS. Are we there? Okay. How about this one? Obtuse, angles that are greater than 90 degrees. So how about angle PQS or angle TQR or angle PQR, TQS? That's only 90 degrees. Okay. All right. Where I want to get to, though, is this one, transversal. Look up, please. A transversal is a line that intersects two parallel lines, like this, like this, like this. My two parallel lines are right here. Here, this is my transversal. Parallel lines here, this is my transversal. Parallel lines here, and this is my transversal. And it created a specific property. Look up, please. The property being that the first one is that it creates corresponding angles. What does that mean? That angle 1, 2, 3, 4 will correspond to 5, 6, 7, and 8. And just right there for a second. And what does that mean? It means that angle 1 corresponds to 5, which means it measures the same. 2 to 6, 3 to 7, and 8 to 4. Same thing here. Alternate exterior angles. This is angle 1. This is angle 7. What do you notice? That they are the same measure. Angle 2 and angle 8 are the same measure. Or alternate interior angles, which is 4 and 6, 3 and 5, also measures the same. And like I said, this is just review. I hope we're getting to the point where everybody's doing this like really fast, yes? So we're like, yeah. Home play, it's up here. Home play is a play sheet. There is tutoring today. If I don't see you guys tomorrow. Bye.